On a canoe trip, time upstream, a distance of 10 kilometers. On the return trip downstream, the average speed of the canoe was 5 kilometers greater than its speed upstream. So what I'm going to do for this one is I'm going to create a bit of a chart of what's happening here. So in my chart, I have upstream and downstream. And we're dealing with distance, speed, and time. Would you agree that distance in both upstream and downstream is given to us to be the same? It would be 10. The speed upstream is slower than the speed downstream. Okay? So upstream, I'm going to use a variable s. And downstream, it is going to be 5 moles. And we do need to know some formulas, how distance, speed, and time are related. Okay? So in this case, do you know, I think I like to start off with speed. When you're traveling a car, what are your units of measurement for speed? You're usually traveling in something kilometers per hour. Your speed is always measured as a distance divided by a time. And with this, you can rearrange this formula and say, if I multiply by time and divide by speed, I have distance is speed over time. Did your teacher ever do this triangle thing? You ever do this triangle thing? Where if you want to find speed, you cover the speed, and oh, it's distance divided by time. If you want to find time, you cover the t, and you have distance divided by speed. If you want to find distance, it's speed times time. I don't know if you've seen that before. It's kind of, I generally just start with, I know speed is kilometers per hour, so I have this formula easily. For me, this is the formula that's easy to remember, because I know how fast my car goes. It's always kilometers over hours per hour. Then I rearrange it. So what we can do here is we can figure out the time for upstream will be 10 divided by s, because time is always distance divided by speed. And the second one will be 10 over s plus 5. What is the total time in terms of speed? The total time will be 10 over s plus, I'm going to leave some space actually here, plus 10 over s plus 5. If I want to add those together, I need a common denominator. So this one needs the s plus 5 and the s plus 5. And this one is going to need an s and an s. So now I have a common denominator of s times s plus 5. And my first one, once I multiply it out, will be 10s plus 50. And the second one will be 10s. Do we have common denominator? Yes. Do we have like terms? Yes. I'll get 20s plus 50. That gets grouped together over s times s plus 5. I could factor a 10 out of the top, but nothing will simplify. And so this is our simplified expression for the total time in terms of the average speed. And we're going to need to do lots of this once we get to the word problems in 7.6. So just practicing, again, I find this chart really, really helpful for organizing your data and for making your data all in terms of one variable. I just use the average speed upstream as s and could solve everything else.